What is a watt? Just to refresh on some basic theory, can be expressed in many different ways: RF or AC power, voltage, current, resistance, or heat and time. Final accuracy depends on the individual accuracy of individual components. Calorimetric measurements involve dissipating heat. RF energy is heat, and 1 BTU per hour has an electrical equivalent in watts of 3.4192 BTU per hour. There are a couple basic calorimeters that Bird Electronic came out with back in the 70s. And if you look at the bottom of the left picture on the right side, that's where the water comes in, goes through a flow meter, past a thermometer, and into a water-cooled load, and past another thermometer on the outside. So you take the difference in temperature and the flow rate and feed all that through an equation, and it tells you how much power you have. And Bird sold those for quite a while, sold quite a few. And actually, in real world, their accuracy is probably better than 1% with the proper selection of the flow meter and the thermometers. They're very, very specialized thermometers. There's a couple of watt meters. The one on the right is the Bird 43 that anybody who's in the Navy has probably seen in doing electronics. The one on the left is a coaxial dynamics version of the same thing. Unit was developed by a company called Dielectric Products in Raymond, Maine. There were several ex-Bird people there, and I don't remember who was responsible for doing it, but Coaxial Dynamics bought that from Dielectric Products around 1983. So a coaxial line, this is what we're all dealing with, whether it's cable or whatever. And that's how you calculate the impedance of a coaxial line. It's fairly simple formula. And why 50 ohms? 75 ohms has less attenuation, and around 30 ohms you can get a lot more power. Somewhere around 66 ohms, I think, is the voltage breakdown. So it's sort of a compromise between all three of them. What diameter really to use. And here's some numbers over where the maximum power capacity occurs, and that's based just strictly on dimensions and voltage breakdown. So the impedance for minimum attenuation is 77 ohms, and it's suspected that this was the overriding factor in picking that as a standard in CW transmission. But later, when low loss dielectrics were developed, things changed, surprisingly enough. If you go back to that other formula and take the dielectric constant of polyethylene and plug that into a formula for a 77 ohm air line, and fill that 77 ohm air line with polyethylene, you end up with 51 ohms, which is kind of convenient, which is where we ended up today. This is the basic innards of both the coaxial dynamics and the Bird wattmeter. Strictly a piece of transmission line with a little coupling loop inserted into it. Sample the voltage and the current in the line, and feed it to a meter and read it on a meter. A little better schematic of what's in an element. The M is a mutual coupling loop. And on the other side, on the right side at the top, there's really a capacitor there. So between the capacitor and that coupling loop, you have a resonant circuit that's loaded with a resistor, and to give you some broadband capabilities. And the C is just a coupling from both the loop itself and the resistor. A little tab that gives you a voltage sample. So that side gives you a voltage sample across the resistor and the capacitor, and the inductor gives you a magnetic field coupling, so you can get both the voltage and current flowing in the line, and a representative sample of both. This gets a little tough, but the forward wave, as it travels from the source to the load, it has a voltage of E forward and a current of I forward, and reflected is just the opposite, E reflected and I reflected, and you're going to be able to measure both voltage and the current by turning that element around, because the coil will measure the current or sample the current in one direction, and if you turn it around, it's going to sample the current in the other direction, but the voltage stays the same, so you're going to get the difference. And because of the trying to broadband these elements as wide as you can, this is from the bird chart, bird catalog, or I think it's a manual from the Model 43. The higher the power of the element, the flatter it is, because you can use a little larger components, higher values, and you don't need to be coupled quite as tightly to the center conductor to get the voltage and the current you need to actually measure some power. Back, I believe in the 50s, Warren Bruin came up with a coupler design. And we're not going to go through the whole circuit here, but basically it's the same thing. You have a coupling capacitor on either side, and the toroid in the middle is a coupling loop, and they use the same coupling loop for either side. And rather than just turn the element around, he took that coupling loop and sampled from both sides and had some calibrating resistors to measure both forward and reflected. And this was used in the Collins 302C transmitter and wattmeter back in 1960. I'm not sure who came first, whether this design came first or whether the bird element design came first. I know the bird 43 was developed in 1951 or 52. And I'm not sure exactly when the elements were developed. This type of a circuit works very well for measuring HF power. And if you try and get above probably 100 megahertz, this circuit doesn't work real well. You need to go back to the original first diagram that was there. That will not work very well below 100 megs, or below 50 anyway. You can't get enough coupling at HF with that kind of a circuit to accurately do anything with it. And that's pretty much it. It just gives you a rough idea of how these things work. And if I can get my screen to come back here. I don't know why I lost my screen. Where did it go? Okay, we'll stop sharing. There we go. All right, any quick questions on that?
Yeah, I didn't hear any of that. Can you do it all over again?
Sure.
No, I'm just kidding.
I don't know, it's a very useful, they're both very useful. I spent about 30 years at Bird and still working a little bit for the other guys. So I've been there a long time as well. The accuracy wise, they're both all derived from the same thing. Big advantage for me for the coaxial dynamics one is it has a 4.5 inch meter versus a 3-inch meter. It's a lot easier to read as you get a little bit older. So other than that, they're both great instruments.
Questions for Dave?
Go ahead, Dan.
Wow, I'm glad I stuck around to listen to that. Seeing the use of change in temperature in water and two presumably very accurate thermometers brought a lot of things into clarity about what's going on. And also your last comment about a 3-inch meter being more useful for you than a 2.5. I think we have a lot in common.
I think that's true with a lot of us anymore.
Yeah, thanks a lot. Now I'll go finish eating breakfast.
All right, anything else?
Unless there's some objection, I would move that we light up the breakout rooms.
We
for
can
at
do
least
that.